Hi, everybody. So we're going to talk about how to solve a trig equation today. Before we do that, though, I thought we could go over one or two examples from the homework. So if you don't need these, feel free to skip over this. But I feel like I know I went through number one. I know sometimes I get questions at number seven, so I thought I'd go through number seven. Let's see. In number seven, this is the more complicated side to work with. Just given the fact that out of the fractions just looks a little bit bigger. If you notice, the numerator has an ax squared, a bx, and a c. So we should be starting to recognize that a little bit quicker, that that's a trinomial. When we see trinomials, we should start to think factoring. So in our step one, I'm going to factor that numerator. Okay, and then I could combine these steps into one step if I actually took a kind of second here to think about this. So if I have cosine in my numerator, that means that I'm going to have, if I have cosines in my numerator, that means when I factor, I'm going to have cosines. Well, the idea of factoring is to try to get something to cancel with the denominator. But if my denominator is a sine squared, a cosine is never going to cancel with a sine because they're not the same, so they can't cancel. But I can make sine squared be a cosine if I rewrite sine squared as 1 minus cosine squared x. And now I'm hoping that something will cancel with the numerator. This 4 is going to be a 4 cosine x. Cosine x. Factors of 1 are just 1 and 1, so there's a 1 here, there's a 1 here. I need this to be a positive 4 and a negative 1 so that I get that 3. Okay. Notice that nothing canceled here. These two binomials do not match the denominator, but I can factor the denominator. Okay, very similar. If you think about it as like if I had x squared minus 16, I could factor that into an x plus 4, x minus 4. If I flip that, made it 16 minus x squared, I could factor that as a 4 plus x and a 4 minus x. So same type of idea here. I can take the square root of both of these, so this is a perfect square. So the numerator is going to stay the same. But the denominator is going to become a sum and difference. So the square root of 1 is 1, so that's in the front. And then 1's plus, 1's minus. And the square root of cosine squared is cosine. So this is going to be cosine x, cosine x. Okay, and then by doing that, I can see that these two match. Okay, different order, but addition, the order doesn't matter. So that means then my third step is to say 4 cosine x minus 1 over 1 minus cosine x, and that's what I was trying to verify. Okay, so I would say minimally this is a 3-step problem, but that was also with me doing this right from the beginning. This could also be a 4-step problem pretty easily, and possibly even a 5 if you want to step things out a little bit more. Okay, so things to remember when you are verifying, make sure that you have step 1, step 2, step 3, and you're showing each and every step, and we're not skipping things. I didn't really skip things, I just did two things in one here. I simplified the numerator and denominator. When you are just simplifying and not verifying, you don't need to show your steps, and you can skip things and it's okay because the goal is just to get from the beginning to the end, but verifying step by step by step. Okay, so let's go into some solving. So the objectives today are for you to be able to simplify a trig identity. So that's really just doing more of what we've been doing the last couple of days. And then the bigger objective today is that you can solve a trig identity using what you remember from the unit circle. Okay, so we're actually going to do that first. So at this point, you should have a blank unit circle in front of you as well as notes. And I want you to fill out the unit circle. It's okay if you don't remember much. Fill out as much as you can. So I'm going to set a 5-minute timer. This is going to be kind of boring, but just so you have it up on your screen. So I'm going to set 5 minutes. Fill out as much as you can. Okay, remember a unit circle is made up of degrees. It's made up of radians, and it's made up of coordinates. Even if you can only fill out all of 1 out of the 3, you know, that's okay. I'll show you the answers when this 5 minutes is done, but fill out as much as you can in 5 minutes. Okay, so here's the timer. Go ahead and start. All right, so that was 5 minutes. If you were unable to finish filling out the unit circle, I wouldn't worry so much. As long as some of it kind of came back and you remember, most of it will start coming back as we work these next couple of days. But let me kind of go through and explain some things that hopefully we remember about the unit circle. Um, and then if you need to pause this and fill it out because you weren't able to, then pause this and fill it out. Okay. Things that we should remember. Remember that when we look at radians, remember that all the way around the circle is 2 pi, so half of that is pi, half of that's pi over 2, and then we can count and go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Half of that is pi over 4, and we can go 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, back to 8. Remember that 30 degrees goes with pi over 6. Remember 6's and 3's go together. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, back to 12 pi over 6. Okay? So 6's and 3's go together. 3's and 6's go together. 4's and 45 go together. Anytime you have a denominator of 2, that's got to go with an increment of 90. So either this 90, or this 90. Okay? Remember coordinates wise, this triangle right here, to get to this, we would go a further distance to the right than we do up, which is why it's root 3 over 2 first, then 1/2, since root 3 over 2 is bigger. Whereas this coordinate right here, we have to go over 1/2, but then we go up that tall distance of root 3 over 2. Okay, all 45s have the root 2 over 2. Okay, anything with 1's and 0's are the 90-degree increments here. Okay, but if you need to pause, go ahead and pause and then finish filling this out. All right. So before we get into solving, we're going to do a little bit of evaluating, which is what we did in the unit before the end of the semester. So this will kind of help us springboard into what we're doing today. All right, it says use the unit circle, no calculators, obviously, to evaluate the following trig ratios. So remember that when we see sine is talking about y. So that means that where is y this? Okay, or we think y, and remember the denominator 4 means we're talking about a 45-degree angle. So if I look at my unit circle, 45 degrees would be there, and I want to know what is my y value when I'm there, and that would be root 2 over 2. Okay. Over here, cosine's talking about x. The denominator 6 is talking about a 30-degree angle. So if I draw out my unit circle, 30 degrees would be here. So x is talking about movement to the right, which you can see is farther than the movement up. So that means that would be root 3 over 2. 11 pi over 6 is all the way around here, just shy of going around my circle. So that means that x value would stay positive. Okay. Last one over here, tangent is talking about y over x. 6 means we're talking about 30 degrees. So 30 degrees is here. My height is 1/2, and my movement to the right is root 3 over 2. This is talking about 5 pi over 6, which would be right here because it would be pi over 6 short of 6 pi over 6. Over here, my x value is negative. I have to go left, so this would be negative. Okay, I multiply by the reciprocal, which means I've multiplied by negative 2 over root 3. The 2's cancel, leaving me with negative 1 over root 3. Rationalizing, I would do this, which we may not need to show this step, which is fine. And that's going to equal then negative root 3 over 3. And then that would be my final answer. Okay, so that's evaluating. Evaluating means that we have one answer. If you recall back to last unit, the last thing that we ended with was talking about arc, cosine, arc, sine, and arc tangent. And if you remember, when we talked about these three, we had to limit which quadrants we were working in. So arc cosine was talking about these two quadrants. Arc sine and arc tangent were talking about these two quadrants. Okay. The reason that we only looked at 2 out of the 4 quadrants is because we were evaluating. When you evaluate, you can only get one answer. Okay, you can't put a number into an equation and get 2 different outputs. It's not possible. However, when we solve, like we are here in these problems, The nice part is we don't have to limit. We can look at the whole unit circle because we want to know everything that satisfies the equation. We want to know sine of what equals -1/2. And it doesn't matter if there's 2 or 3 or 4 or 10 answers. I want to know all of them. Okay. This interval is the same interval that we dealt with last unit, but I'm just going to write it out so that we see. This means, so write this out, this means everything, so this is all x values, so everything, actually, change that, not everything. We're going to say all x values between 0 and 2 pi, including 0. Because notice that there's an equal to symbol here. Right, if we think about our unit circle, 0 and 2 pi are both here, and we can't call them the same thing. We have to call it one or the other. And based off of this interval, we're going to call it 0, not 2 pi, which is consistent with what we did last year. Okay, our goal, when we solve is to get down to something that looks like cosine x equals something, sine x equals something, or tangent x equals something. If we can get down to that point, then we can say cosine is talking about x, sine is talking about y, and tangent is talking about y over x. Okay, so that's my goal, to get there. All right, so if we take a look at number 1 here, notice that we don't need to do any type of manipulation with my equation. It's already sine x equals. So sine means that I'm talking about y, and I want to know where on my unit circle do I get y values of -1/2. And I want to know where all of those are. So my height, if my heights are negative, it means I'm in these 2 quadrants. Okay? And if you think back to your unit circle, y is your height, right? So you have heights of -1/2, -√2/2, -√3/2, and then finally down here at 1. So I go down a little bit more, all the way down to 1. Okay? Erase that for a second. So if I go down 1/2, that means I'm here, and I'm also here. Very close to that x-axis. That means that my solutions, this would be 6 pi over 6, so that next one to that point would be 7 pi over 6, and this is almost all the way around, so it's 11 pi over 6, just shy of 12 pi over 6. Okay, and these would be my 2 solutions. So notice that I have 2 solutions. Okay, solving means that either of those, sine of either of them, are going to give me -1/2. Okay, and we do write x here, even though that we're looking for a y value, because notice the equation has an x. So I want to know what can I substitute in for x to get that -1/2. Okay. Over here I have secant. Secant is the reciprocal of cosine. So what this means is I can change secant to cosine x, but to get secant to cosine, I would have to flip this. And if I flip the left side, I have to also flip the right side, so that I can keep this in equal equation, and I haven't changed it. So I flip the left to make a cosine, which means if I flip the right, I get 3 over 2 root 3. So basically I just did the reciprocal of both sides. Okay. I'm not done. Even though this is cosine x, there is no coordinate on the unit circle that looks like this, so I rationalize it. When rationalizing it, I just need to multiply by the root part. So that gives me 3 root 3. This right here means that this is going to be 2 times 3, which is 6. Okay. And 3 over 6 is 1/2, so that means that this simplifies to root 3 over 2. All right. So cosine's talking about x, so I want to know where on my unit circle do I have that x value. So if I draw out my unit circle, x values are movements left and right. In this case, right because it's positive. So I have a positive x value in both of these quadrants. So root 3 over 2 means I move almost as far over as I can go. So I would be here and here. So my solutions would be pi over 6. And this one's just shy of going all the way around. So it would be at 11 pi over 6. And those would be my 2 solutions. Okay, so let's try another one. This one is already solved for us. There's nothing we need to manipulate. Cosine x just means that I want to know when is x is 0. So if I think about my unit circle, my x value is 0 up at top and up at bottom on the y-axis. Okay, here I would be x is 1 and x is negative 1. So my solutions would be pi over 2 and 3 pi over 2. And you don't need to write them in order in which ones happen first. It's just normally we do just because it's easier to do it that way. Okay. Over here, sine means y, so I want to know when is sine 3 over 2. Well, 3 over 2 is the same as 1.5, so just be careful. This is not talking about root 3 over 2. It's not a typo. So I want to know when is y this. Well, 3 over 2 is 1.5. So if I think about my unit circle means that the radius is 1 everywhere. So if I want to know when is my y 1.5, that means that really I'd be like out here, but that's not part of my unit circle. So in this case, no solution. Okay, so this is just kind of one of those to make sure you understand the unit circle. Everything's 1 or less. All right, go ahead and flip over. On the back side here, we have two equations that we're going to need to do a little bit more manipulating with. Notice in number 5 that I have 3 terms. I have 1 term here, 1 term here, and 1 term here. Okay? I have 2 of the terms have a cosine x. Okay? In order to solve, I want to get those cosines on the same side. So what I'm going to do is I'm going to move this one over. So I'm going to add root 2 cosine x. I'm not dividing, I'm pulling that whole term over, which is why I'm adding it. So I'm going to add root 2 cosine x. So when I add these, I have one of these plus another one, which means I have 2 root 2 cosine x. So 1 root 2, another root 2 means I have 2 of them, plus 2 equals 0. Okay, and now I know that there's a cosine in here, but think about it this way. This is very similar to a problem that looks like if I were to say, like 3 over 2x plus 4 equals 0. If I want to get x by itself, I'm going to subtract 4 and then multiply by the reciprocal. Right? I'm just going to undo each of those things. Okay. So here I'm going to subtract 2 first, which gives me 2 root 2 cosine x equals negative 2. Then I'm going to divide by 2 root 2, which is going to leave me with cosine x equals, these are going to simplify to give me negative 1 over root 2. And then I can rationalize this. So multiply by root 2, which is going to give me negative root 2 over 2. And at this point is where I should go, okay, on the unit circle, I know that this coordinate comes up, so I know I'm on the right track here. Cosine means x, so I want to know when is x this. Okay, so here's my unit circle. Cosine is negative in these 2 quadrants, so it's always a good place to start. Root 2 is talking about a 45-degree angle, so that's here and that's here. Okay, so that means I have 2 solutions. And I would just count this and go 1 pi over 4, 2 pi over 4. That's 3 pi over 4. And then 4 pi over 4 makes that 5 pi over 4. So those would be my 2 solutions. Okay, so notice everything right now has had 2 solutions. We're going to get to one now that has a couple more. They don't all have to have 2 solutions. Sometimes they only have 1, sometimes 2, sometimes 3, sometimes 4, sometimes more depending on if we change an interval. Okay. All right, this one, the sign is almost by itself. In order to undo a squared, I take the square root, so I have to square root both of these sides. That's going to leave me with sine x, which is what I want. Remember that when you take the square root, plus or minus, 1/2 is not a perfect square, but I can take the square root of each of these individually. So the square root of 1 is 1. The square root of 2, I'm just going to leave root 2, which means I need to rationalize it. So I'm going to say sine x equals plus or minus root 2 over 2. Okay, so I want to know on my unit circle, where am I going to get a y value that's that? Now, I'm going to actually break that up just so at least the first time we can see this. So this is saying, when is sine of x positive root 2 over 2? And then it's also saying, when is sine x negative root 2 over 2? So if you think about how we've done the other problems, this is going to give me 2 answers, and so is this. So that means I'm going to get a total of 4 answers, all because of that plus or minus. Okay, so I want to know, when is y going to give me positive root 2, and when is y going to give me negative root 2? I'll draw my unit circle. When is my y positive root 2? That would be up 45 and up 45. When is y negative root 2? That would be down 45 and down 45. So that means that my answer is x equals, again, x, because if I go back to my equation, that's what I'm substituting in for. The first one is pi over 4. The next one is 3 pi over 4. The next one is 5 pi over 4. And the last one is 7 pi over 4. Those would be all 4 answers. Okay? All right, at this point, this is done. You guys can turn in your notes and get your homework. I want to show you 2 on your homework, though, that are going to help you fill everything out. So you can pause this, go get your homework, and then start watching again to listen to the next 2. Okay. So on your homework, I want to go through number 3 and number 4, just because they're tangent and cotangent. I forgot to throw them in the notes. So one thing I wanted to remind you of, if you remember back to last semester and last unit, we had tangent when we evaluated, tangent root 3 over 3, and then sometimes we had tangent of just root 3. When we talk about tangent, we talk about these, they happen at a 30 and a 60 degree, not a 45, because if it happened at a 45, you would do root 2 divided by 2 by itself. You get 1. So anyways, root 3 over 3 happens at a 30 or a 60, which means then this happens at the other one. And if you remember back to last semester, I said that if you add these, 3 plus 3, that gives you pi over 6, and that's how you remember that that happens at pi over 6 or 30 degrees. And 3 plus nothing is 3, so that happens at 60 degrees or pi over 3. Okay, so in terms of number 3, that means that you want to know, when is y over x going to give you this, right? So this is where I'd say, well, 3 plus 3 is 6, so that's talking about pi over 6. So pi over 6 is right here. Tangent of y over x, if you're getting a positive, that means it's got to happen in this quadrant or this quadrant. This is going to be a positive divided by a positive, negative divided by negative. Okay, so it's got to be one of these 2. If it was a negative, it would have happened in these 2. Okay, so one of my answers is going to be pi over 6. And then this answer over here is going to be, here's my x-axis, pi over 6 further. So that one's going to be 7 pi over 6. So that pi over 6 right here is my reference angle. I go up pi over 6, and then I continue to go pi over 6. Okay. Cotangent, instead of y over x, is x over y. So I want to know, when am I going to divide 2 things and get a 1? Okay. Sometimes we get this confused and we think like we're here or here or here or here. Remember, those have zeros and ones. So if I divide 0 and 1 or 1 and 0, I either get 0 or I get undefined, which is not what this is saying. Okay. So this is saying, when am I going to get 1? Well, I'm going to, first of all, get a positive 1 in this quadrant again, or this quadrant. If it was a negative 1, it would have been in these 2. Okay? And the only place that I can get a 1 is when I divide a number by itself. So that would be a 45 here and a 45 here. So that means I'm going to say x equals, this coordinate is pi over 4. And this one would be going 1, 2, 3, 4, 5. 5 pi over 4. Okay? Or if you wanted to, you could say cotangent is tangent if you flip it. And if you flip 1 over 1, you get 1, and you could treat it like tangent. You're going to get the same answer. Okay? Things like number 5, just make sure that you flip secant. If you flip it, or the reciprocal would be cosine. But if you flip this, you get 1 over 2. Not negative 2, not still 2, but 1/2. Okay? All right. The rest of this is yours. It should just be a lot of good practice. Some of them are very simple, like, 7, 8, 9. And then problems like 10, 11, 12 get a little bit more algebra in them. Couple problems in the back. Some of them are straightforward. Some of them take a little bit of work. And then I got a couple verifying on here. And when we come back on Monday, we'll do a little bit of solving with factor. Okay? All right. Thank you.